In the manual straightening lesson, you hand tweak the power values of the two motor commands to make your robot move straighter. Even so, the results were not always spectacular. There were simply too many unknown and changing quantities to be able to compensate for them all ahead of time. However, if we watch for them while running, we can correct problems that come up. In this lesson, you will learn how to use the encoders to straighten out the movement of the robot. First, we have to spot the problem. The robot moves straight when the wheels are together. If they move at different speeds, or in different directions, the robot turns. We can check the togetherness of the wheels by looking at the encoders attached to each side. If the value of the right encoder is different from the value of the left encoder, the robot is off course. In fact, by looking at the two values, we can even tell which way the robot is turning. The encoder with more counts is ahead, and the encoder with fewer counts is behind. To correct the robot's forward movements, we needed to continually adjust the motor powers to push in the opposite direction from the way it's drifting. If the right wheel is ahead of the left wheel, the right wheel should slow down and let the left catch up. If the left wheel is ahead, it should slow instead. If both are exactly together, then both wheels should run at the same power. The keyword here is if, a conditional statement that will allow us to implement these behaviors in Robot C. An if statement is a conditional statement that works similarly to a while loop. Like a while loop, an if statement checks the condition between its parentheses. And if the condition is true, the commands in between the curly braces are run. But if the condition is false, the program skips over the commands and moves on in the program. Unlike a while loop, however, an if statement only runs the commands in its curly braces once, before the program moves on. Using the if statements to continually monitor and correct its path, the robot should be able to drive straight, even with the motor variations that plagued earlier methods. Great! In this lesson, you learned how to use the encoders to have the robot self-correct its forward movements. Move on to the next lesson to implement what you just learned in Robot C.